And you seem to have a live feed here, so if you don't need to look up.
Oh, yeah.
Okay, so good to go. Okay, now take the next 5 minutes and then you have it. Hey, folks. We're just about ready to start. So as I mentioned today, we're starting a little bit later just to make sure that there are no stragglers. You're new on campus. Okay, well, my name is Stefan Krastanov. I am a professor here at the physics and CS departments. I'm also a principal scientific software engineer on the compiler team at Quera. And I'm one of the volunteers that are helping organize this event together with a bunch of other co-conspirators. First of all, welcome here. Thanks for coming. I hope you'll be having fun over the next very intense 5 days. In terms of the schedule, speaking of intensity, we'll have about 9 hours of lectures every day. There'll be a morning session from 9 to 12, an afternoon session from 2 to 5, and an evening session from 7:30 to 10:30. And how specifically they're organized will really depend on the lecture at the given time. A lot of the lectures will be very hands-on with time for you to actually practice and implement things for yourself. We'll be going on Monday, well, today, we'll be focusing mostly on various introductory skills and first principles of high quality, high performance software engineering. On Tuesday, we'll be doing state vector simulations and a little bit of Clifford circuit formalism that's more specifically useful for large-scale quantum error correction simulations. On Wednesday, it will be focused on tensor networks for most of the day, which is a very important...
Sorry, I don't know if people further forward can see, but the glare is enough that the bottom 2/3 of the screen are not.
I will fix it shortly. We are, yeah. On Wednesday, we'll be focusing on tensor networks for most of the day. A very important, very general technique for capturing the dynamics that might be easy to simulate on a classical computer, even though they're quantum dynamics. And we'll also have a session on high performance programming on accelerators like GPUs. On Thursday, the whole day will be focused on optimal control, a little bit overlap with robotics. Actually, a bunch of the lecturers have robotics background and they jumped into quantum information science. These are techniques where you use something along the lines of automatic differentiation and gradient descent in order to figure out how to control a system efficiently. And on Friday, we'll be focusing on quantum network simulations. That's actually really the main source of funding for the summer school and how you're getting to have, for $90, basically meals for the entire week. Okay, for pretty much the entirety of the summer school, we'll be using the Julia language. And the lectures themselves span from enthusiasts to fanatics in that tooling. But the more justifiable reason we're sticking to that language is, besides the fact that we're all big fans of it, is that it's a really easy platform on which you have the easy way to jump into it, like in Python, a lot of interactivity, a lot of minimal requirements to get into it. But on the other hand, the lessons you learn in that language translate really well to any other high-performance tooling, while teaching you how to use JAX in a high-performance setting doesn't really translate very well to most of the other languages that exist. So there will be a lot of first principles that will be taught. As I mentioned, the summer school is funded through the generous support of the National Science Foundation and the Center for Quantum Networks. So if you have friends there, say thanks to them, especially now with the rise of authoritarianism. It's kind of difficult to get funding for this type of events. So definitely a lot of gratitude to the hardworking folks there that made this possible. We probably will be sending you surveys over the next year so that we can hear from you about whether the summer school was useful. Please try to respond to those surveys because they really help inform how we need to proceed with the summer school in future sessions, and also to justify to the National Science Foundation whether it's actually worthwhile to pay for your meals. In terms of us being here, please be cordial and respectful to each other. If there's anything that you cannot resolve on your own, don't hesitate to contact me or anyone else of the organizers. We're here to help. So the code of conduct is a general don't be jerks. And of course, that's not a well-defined code of conduct, so we're here to help if there is issues with the definition of that. All the lectures will be recorded. We'll try to process them into something that's available online later on. It kind of depends on the quality of the AV, but that means that while you're in the room pickups will be capturing what you're saying. The goal of this is so that we have the Q&A be understandable on the recording online, but it also means that if you're gossiping about a friend, that might be recorded. Of course, we'll be cutting out the spacing between lectures, but just so you know, the recordings are happening. And again, if that's something that's troubling you, just let me know. So with this, we'll be starting with the first session. We'll have Raye take care of you for the entirety of the day today. Raye is a long-term member of the Juliaup out of Massachusetts Institute of Technology. Well, you were. Yeah. And recently moved to Princeton. Long-term chair of the Juliaup organizing committee and contributor to much of the base infrastructure for Julia and especially the linear-algebra framework in it. And with that, take it away.
Alrighty. Can everybody hear me from here? Is this good? All right, perfect.
Sorry, wait a second. For the lighting, can you set up two different number configuration for the lights?
I am playing with it right
Oh.
now.
Oh, there you go. Okay, then.
Okay.
Actually, wait, sorry. Right? Can you make your font size bigger? Sorry. Okay, that's great. Beautiful. Thank you.
Alrighty. All right. So as Stefan said, I'm currently a PhD student at Princeton. I work in programming languages, specifically for sparse and distributed computing. I've been a Julia quote unquote contributor for quite some time. You might call me the laziest committer to the Julia language. I have that for some reason. But I have done a lot of community organizing. So I was the chair for the past 4 years or so of JuliaCon. And so I got to interact with a lot of people from across the spectrum of users and developers and scientists. So if you have any questions about sort of the breadth of the community, if you need to find somebody, if you have a project that you need help with and you don't know who to talk to, come see me. I know a lot of people, more than I really should at my age, from, organizing and talking to, I guess, yeah, over 5,000 attendees at JuliaCons for the past 4 years or so. So yeah, if you need to find somebody, let me know and we can get some collaborations and that kind of stuff going. I believe my build has finished, so we can switch over to this website screen real quick for a minute. I don't actually know how to use Zoom. All right. So the first question that you might ask coming into this, if you're not a Julia user, is why use Julia? Julia came out of MIT. It was built sort of to tackle a couple different problems that that the community saw in. Sorry, let me turn off my phone. Hello. Saw with the state of the art in programming languages. On the one hand, down at the bottom here of this chart, here, let me go to the bigger one down here. You have languages like C or Fortran or C++, and those languages are immensely difficult to program. You can spend decades becoming an expert, and you'll be an expert in that language, and you can help people optimize their code, but you'll probably also cost $200,000 a year to hire. And so that really limits the speed of scientific progress. It limits the amount that sort of first-year grad students or undergrads can really participate in software for the scientific process. And sort of it prevents a lot of smaller groups from enjoying the fruits of high-performance computing. And so Julia and the other language that produced this chart, as you can imagine, Chapel, both intend to sort of target this regime where you have a very sort of easy to program language. The compressed code size is relatively small, the smallest of any of the languages on this part of the chart, although I think there's some smaller up here, like Ruby. But you get performance that is approximately the same as Fortran or C#. In the case of Chapel, if they're really trying really hard, they can get close to C. And Julia can get there too. There's a lot of micro benchmarks that show this. This is sort of one particular micro benchmark game, but it shows Julia is on the sort of Pareto frontier of easy to program and fast. And so that's really the big reason Julia exists today. It was built for linear algebra as its first sort of big audience, and it has grown far beyond that today. So the thing that Julia is good at, the things that make it usable for us, mere mortals. The first one is multiple dispatch. We'll talk about that a little bit later, but it's a style of programming that really suits sort of the real world, scientists, people who interact with physical phenomenon. It is very much unlike the sort of single dispatch world of C++ or Python, and we'll see a bit more about that later. It's JIT compiled, so it's interactive, and you get very fast code without sort of paying for it all the way up front. Now, a lot of people will tell you that's a huge problem. You have to pay for it as you go. And there's a lot of work to fix that. And we'll talk about that, I think, tonight when we talk about different ways to compile Julia. It's really great for array programming. If you do linear algebra, if you do sort of, I wouldn't say machine learning, because you probably want to just go to Python for that. But if you want to do automatic differentiation, all sorts of things that involve a lot of linear algebra, tensors as well. Array programming in general. It's really nice for scientific computing because we have access to symbols that you don't have in most other languages or are not commonly used in most other languages. So you can write your code that looks exactly like the math that you saw on the blackboard. The other thing is that we won't talk about this much because I don't encourage you to do it, but Julia descends from the Lisp series of programming languages. And so it has very powerful metaprogramming, macros. You might be familiar with from some other languages. I won't teach you much about that because you really shouldn't be writing macros unless you really have to. There's really good interoperability with C, Fortran, Python. Excuse me. Stefan in here? Katie, are you in here?
Yes.
Could you find me some water, perhaps?
Yes.
Thank you. It also has a built-in package manager, which is first class. Sort of like Cargo and Rust, and very much unlike Python. If you've ever used Python and dealt with, UV, pip, conda, and virtual environments, all those issues in the Python ecosystem. It also has composable parallelism, so you can use threads within Julia. You can use distributed memory. So on a supercomputer as large as Frontier, the largest supercomputer in the world in, I think, Tennessee. And you can also program for the GPU natively in Julia, which is a big deal compared to other languages. And finally, it's open source. So compared to its most direct predecessor, MATLAB, you do not have to pay for Julia itself. And you do not have to sort of deal with licensing and things like that. So for the rest of the day, we'll split up into sort of 6 sections of tutorials. The first one will be just getting started with Julia. The second one will be Julia types and dispatch. We'll probably do both of those this morning. We'll have a bit more about types and dispatch in the afternoon. And then we will talk about how to write fast Julia code and tools that can help with that. Finally, in the evening, we'll talk about HPC, distributed programming, GPU programming. Not too much GPU programming because it is difficult and I don't know what GPUs you have on your computers. so I can't necessarily help you if something goes wrong. But we'll talk about it. I'll show you how it works, and we can give it a try. If it doesn't work, you'll know how to use a cluster if you have access to one. And finally, towards the end of the day, we'll do a quick tour of parts of the computational ecosystem in Julia, and I can also help with any questions, sort of hackathon style towards the very end. A lot of people enjoyed that last year. Alrighty. So the first thing, does everybody have Julia up installed? Raise your hand if you do have Julia up installed. All right, that's pretty much everybody. If you do not, this website is QNumerics.raygun.com. Spelled like my first name up there. I don't know if you can see that. Can you zoom on the? Anyway, thank you very much. If you do not have Julia up installed or Julia installed some other way, please let us know. So one thing I'll ask is if you go ahead and open Julia, so call Julia in your terminal. If you have it installed with an icon, sometimes on Mac OS or Windows, click on that. And then if you don't mind, I'm going to do this a lot, pull down this little screen above. But if you don't mind typing in version or just looking at the little bar here at the top, let me know if you have something below 1.12. If you have something below 1.12, I can't guarantee that all of the tidbits that I have going on will work. Julia doesn't typically do major breaking versions, but there are features that I may use that are only available in 1.12 or above. The current LTS version, I believe, is 1.10, which is quite old at this point. And the current release candidate is 1.13. Probably will come out sort of August or later. If you installed Julia with your package manager, so if you did brew install Julia or apt install Julia, please Julia up. We get countless bug reports, or have in the past, of people having issues with the package manager installed version of Julia. That's because Julia uses the LLVM compiler, and it uses a sort of vendored version with some extra patches quite frequently. And so when the package managers try to package Julia, they use their own version of LLVM, and then you quickly run into bugs because they're not carrying the patches that are typically used in the Julia world. That may no longer be true, right? They may have fixed these things recently, but for quite a long time, we have recommended that you install Julia through Julia up, or just by downloading a single binary at a time, like Julia 1.12. All right. So, is this one zoomed too? I'm going to show a little bit about Julia up because there may be other teachers here this week who need a different version of Julia. For instance, sometimes the autodiff frameworks need one that's one version behind because they're very complicated and they need the compiler. So one thing you can do is you can look at the status of your current machine. So I currently have 1.7, 1.11, the development version, which is just my sort of local repository for Julia, the nightly version, which is 1.14, and the release version, which is 1.12.6. Hopefully you all see the little star next to the release version for default. If you look at Julia up list, you will see all the versions of Julia all the way back to, I think, 1.0. Oh, you can even go back all the way to 0.7, although I don't recommend it.
So how do you go from like the Julia with the caret to the squiggly thing? Because I think Julia with the caret's not giving me the Julia status, Julia up status.
So what do you see for Julia up status right there?
It just gets an error.
You mind if I take a peek?
I think I think you did something which switches from the caret to the tilde.
Oh, this is Julia itself, not Julia up. So just go to a normal terminal.
Okay, yeah, sorry.
Yeah, sorry, this is just, we haven't yet entered Julia, or I haven't at least. Yeah, so I think you're probably already on the release anyway, but yeah, that's just for the Julia up tool, but it's very valuable in case you need to go back a version or go forward a version. We'll be using Visual Studio Code extensively, especially later in the course. It's really valuable for debugging. You can open Julia notebooks in it. It has sort of an interactive REPL installed within it, so you can do REPL-driven development inside your editor. So highly recommend you use Visual Studio Code. In addition, you can find the Julia extension, just search for it within VS Code. Otherwise, there's a link here, which doesn't seem to be actually a link, it's just some text. But it's easy to find. All righty. Let's see, let me just go back to this one. All right. So my first question is, how many of you have used Julia for more than 2 months? Okay, not too many, actually. All right, good to know. So we can kind of start from the beginning. I'm sorry to those of you who are experts. It'll take a while for us to get there, but hopefully towards the evening and night session, we'll talk about some more advanced topics that may pique your interest. So we're in the native Julia REPL here. Julia has a very nice REPL compared to a lot of languages. If you've ever opened the Python REPL, for instance, you know it's just black and white. There's no highlighting. You can always install another REPL, but Julia's is native and quite nice. It has 4 modes that you should know about. The first one is what we're looking at here. It's just basic Julia. So, you know, I can assign variables, A and B. I can add them up like a calculator. Let's see, I can reassign variables. And then you will see I probably can't add them up. The second REPL mode that you need to be aware of is the right square bracket. That takes you to Julia's package manager. Actually, let me open just a fresh REPL here. This was probably what it will look like for you if you are not already in a project. But this is the package manager. You can say help, and you will see all the available package management things that you can do. So you can activate, which sort of activates a project, activates a folder. You can add packages to a project. Build is not super common anymore, to be honest. Let's see, what else might you need? Status. So if I go over here, I can do status, and I will see all these packages that are sort of actively in my project right now. The second terminal menu, REPL menu that you should be aware of is the help menu. You can look most things up here, more things than you would think. So let me see if I pull up. How do I? Hello. I think my computer's frozen. No, okay. Emoji. Apologies.
I have a question. So I tried just to look for the status, and for whatever reason, I get like a undefined variable error for status.
Are you in the package REPL? It shows like 1.12. It should look like this. Julia, and then like this. Does it look like that? Yeah. So you need to hit your right square bracket.
Oh, okay.
And then you'll be in the package REPL. So that's one of the modes, and you can hit backspace to get out of it.
And how did you move to that help? Like you kind of did something which changed the Julia caret to help caret.
Oh, sorry, did I not say that? The help one is question mark.
Question mark. Oh, okay.
So if you're at the REPL and you need some help, just type question mark. Note that this only really works if it's the first character, right? If you're typing things and you type the question mark, that probably means something else. It's the same with the square bracket and then the other things that we'll talk about. So yeah, in the help menu, I can do things like ask about symbols. So do I have like word wrap available? Hang on. Can everybody see that low on the screen? This was a problem last year. No? Okay. I'll just try to keep up here at the top. So you can ask about modules. For instance, base Julia, that is pretty much all of Julia that you will interact with. There's also core. You will probably never interact with this unless you are an expert. Core is sort of the very bare bones of the language required to compile itself, essentially. I can, let's see, I did this earlier. I can ask about A. It'll tell you, we have no documentation for this, but I know it's of type int64, the 64-bit integer. And it'll tell you some other things here. For instance, that int64 is a primitive type. We'll get into types later, and it'll show you the type hierarchy as well. All right. We can also ask about emojis. So you can use emojis if you feel really cursed, if you want to make all of your collaborators sort of have to search for emojis on the internet, paste them in, and then type them. But yeah, so we can use emojis, wink, and then you do tab to complete, and then 10. I can also do typical LaTeX symbols. So, most of the Greek symbols, I can do subset, I can do, epsilon. I can do one common one you might see me use more than I really should is in. It's a synonym for the literal in. Or you can do not in, right? So there are a lot of Unicode symbols. If you are interested in doing math that is sort of legible as math, you are welcome to do so. I don't really recommend it if you're actively developing the code because it makes typing take that much longer. But if you're presenting code, for instance, it might be valuable for it to sort of look like the blackboard, as I said earlier. The Greek symbol. So this one is a little bit, sometimes you may have to look this up like I did with the emoji, right? But typically they are something like their LaTeX, if you're familiar with LaTeX, sort of command. So gamma, capital gamma is capital gamma, undercase gamma is, or lowercase gamma is lowercase gamma. And you do tab to complete, in case I forgot to mention that. So most of the symbols have somewhat similar names to their LaTeX counterparts, but not all of them. And so if you ever find one that you can't figure out what it is, just paste it into the REPL, or into the help REPL, and it'll tell you how to type it. I believe I've gotten way ahead of myself here. Yep.
So can the help you figure out what variables are assigned?
No, there's no, as far as I'm aware, there's no like workspace in Julia as it stands in the REPL right now. I wouldn't really encourage sort of, I'm not aware if there is one. I can try to find out before, like after the next break or something. I've never used it. After the break, we'll talk about sort of the standard way that we develop packages in Julia. And so there are better ways to sort of see what is in scope. One thing you can do if you really want is to double click tab and you can see every variable, I guess. But it doesn't really tell you much about them, right? It just says these are the available symbols to you that are actively bound. So for instance, these are the macros that I talked about earlier. Luckily, most of them are already written for you. There's a bunch of abstract types. There's, most of these capital symbols are types. We use capitals for types in Julia. And then all of these lowercase ones are typically functions. Double click tab, I guess is the closest thing I have for you. So we can, oops, nobody can see that. So we can look at the help for print line, for instance. It's very much like the print line in C, probably Python as well. So I can sort of I forgot a space there, but oh yeah. So I just showed you how to both print line and concatenate. So the other thing you can do is you actually don't need the concatenation. I can do partner like that, and print line sort of puts everything together. It's a variable argument function. Can anyone guess why the string concatenation is a multiplication symbol? Anyone?
It matches other programs.
Hmm?
Does it match another program?
Yeah, it's the commutativity of it. The early Julia developers, as I mentioned, were very linear algebra focused. They still are to some extent, but it's all about sort of how it behaves. You might think it should be plus, but typically in most algebras, plus can be rearranged, right? 2 plus 2, 2 plus 2, obviously. 2 plus 3 is the same as 3 plus 2. That's not the case for string concatenation, right? So you might find some strange things like this in Julia because people were trying to be perhaps overly rigorous about their mathematics. So yeah, this won't bite you too often, but that's one of the big ones is that a lot of the string functions are sort of a little bit different than they are in other languages. I'm going to skip over packages for just a minute. I'll do this example. So if we go back to the package REPL, we can add a sort of dummy package. So, sorry, I'm going to go to this. So I'm going to, you don't have to do this, but I'm going to activate --temp. So that creates a temporary project. Once I exit this Julia session, I will never see this project again. It will be deleted. That means I can add packages. I don't have to care about what happens. So I can add example. And we can see what happens here. The first thing is resolving. So Julia's package manager will figure out what the most important, sort of not what the most, the highest version numbers that it can access for each package that you add. In this case, because it's example, I believe example doesn't have any dependencies or any dependence, hopefully. And then, it will update your manifest. So you will typically find 2 folders in your packages or in your projects. The first one is, oh my. The first one is the product file. This is a very small one. But this typically just lists your dependencies. So example, and it has a UUID alongside it that your package manager will figure out for you. You typically just have to know the name. But then if I open the manifest, you can see that there's a lot more information in this. So the project is kind of like where the user essentially just names their packages, and the manifest is the record of how the package manager was able to resolve the version numbers between all the different dependencies. And so the valuable thing about the manifest is if I write a scientific paper or a textbook, for instance, and I need to be sure that it's reproducible, I don't hand somebody my project.toml, right? Because they could install it on a newer machine than mine and get a newer version of the packages, or a way older machine, right? Or just a different operating system, perhaps. With the manifest, you are guaranteed to get the exact same versions of every single package in your project. And that aids a lot in reproducibility. It's not perfect, right? There's still some other things about reproducibility, like your data, how it's ingested, that you don't have any randomness in your experiments. But this is a big deal for sort of transmitting information to other scientists. Go away. All right. And if I look at status again, ST is short for status. You typically can't use short names for things, except in the package REPL, much like you sometimes can in sort of your bash terminal. You can see I just have the one example package. I'm going to do something a little silly here and show you what can happen if you sort of add packages willy-nilly. So can I instantiate? Oh, well, if you did that, it would take a lot longer. I already have that package. So there are some packages in Julia that take quite a long time to install. In a few minutes, I'm going to have you all sort of clone a repository and get started on that process because we'll use most of those throughout the day. The biggest, most expensive packages in Julia, can anybody guess what they are? The ones that take the longest to compile? Yeah, it's the plotting packages. For whatever reason, due to their design or something else, the plotting packages, both Mach-E and plots, which are the two big ones, take quite a long time to compile. Sometimes that can be very frustrating, and that's why we use projects. My previous advisor at MIT, one of the creators of Julia, refused to use projects most of the time, and so was very frustrated that every time he opened something to try and show a nice plot to one of his colleagues, that he had to recompile everything again. When I say recompile, I don't mean sort of from everything under the sun, right? If you compile something in C or C++, you compile the whole program at once. In Julia, this is what we call pre-compilation. So it will compile some of the most commonly used things, largely because people grew very frustrated that when you type plot of a line, it could take 20 seconds. It was typically called the time to first plot problem. That's largely been solved by this pre-compilation thing.
Yeah, and also in German, the first time you compile a code, it's a lot of time, but then the second time it's much less time.
Yeah. So it's caching that compilation, typically pre-compilation. So if I do something like does anybody know how to get rid of the zoom bar? Hide floating meeting controls. Perfect. We'll look at this a little bit later, but or in a few minutes. But if I have a function, a times b for foo, the first time I use this, it will be compiled. So you can see for this one is pretty fast, but for a larger function, it'll take a second. But then the second time I do it, it will be instantaneous. You might have seen actually the difference there. It kind of flickered for a second. When you do something like this, and then I exit my Julia, there is no cache that is held here, even if this is held in a project in a file, right? You have to explicitly precompile things in order for it to be cached across sessions. But as long as I keep this session open and I use foo or, I don't know, an ODE solver, that will be, kept in the cache, compiled, ready to use again instantaneously. All right, I'm going to follow the little guide for a little bit, so I stopped jumping ahead of myself. The next REPL mode is under the semicolon. So if you hit the semicolon, you will get a shell. I am in one of my package directories, so I have a bunch of things here. I don't know where you launched Julia. I'll give you a repo that you can launch it in a few minutes to use some of these packages I've talked about. But you can do most things that you would do in a bash shell from this REPL mode. If you have a Windows computer, this is a pass-through shell, so it's passing through the commands. It can be a bit funky. I sort of wouldn't recommend, if you're writing code for somebody else, I would not recommend relying on this REPL mode. It's more of a like, oh, what directory am I in, right? Like I can do pwd to see where I'm at. But if you're going to give code to other people, you should be writing functions. You should be using, the typical interfaces, because this is one of the most non-portable parts of Julia, especially as you go to Windows, because it's very strange. Now, if you're using Julia on WSL, it's just like Linux, right? And if you are on Windows, you should probably be using it on WSL. Nothing there. Interesting. All right. Let's see. All right. So I mentioned earlier that you can bind variables to, you can rebind variables at any time. There's no type for variables. For instance, in C, you might say int of x or x of int, and you can only then store integers in that variable. That's not the case with Julia, unless you do a particular bit of syntax that is pretty rare that we'll talk about later when we talk about types. But in general, you can rebind things to anything else. For instance, here I've bound sigma to the plus function, and so I can add up, 1, 2, 3. I can then rebind sigma to something else. Here I do it to 3. Yeah. You can, like I said, you can do emojis. So this here is what looks a little bit like a tuple. We'll talk about those a bit later, but essentially all of these emojis are assigned to different variables here. So, like that. Now, you notice on the next line that I've added these things up. You might think, oh, false is 0 and true is 1. But I'll show you how to do the about function that I just did here in a little bit. But Booleans are truly Boolean in Julia. Unlike C, you cannot use 0 as false and 1 as true, right? If I do an if statement, I can't put 0 and 1 in there. I have to put true and false. Or I have to do a comparison in order to get true and false. Julia is very particular about having the right types for the right things. Not as particular as like OCaml, if you're familiar with that language. But for things like Booleans, we do try to maintain sort of not using integers. Let's see. Having to keep clearing this. Oops. So I said you could reassign things willy-nilly. That is not the case with a few types of variables in Julia, quote unquote variables. That is function names and struct names. So if I create a function like foo, I cannot rename the function foo. It exists forever, right? Julia doesn't sort of garbage collect functions away. The same is true with structs. So I can change the definition of a function, but I can't, for now, change the definition of a struct. So we'll talk about structs here in a little bit, but everything that we've talked about so far is a struct of some type. Let me see. Let me change this away from foo then. You can't see that, can you? So we did multiplication again there. The other funny thing about multiplication being the function for string concatenation in Julia is that to repeat a string, you take it to a power. So, a string to the third power is that string 3 times. I'm not sure how often you really need this, but it is an interesting thing about Julia. If you care much about strings, which I doubt a ton of people here are super interested in string processing. There are some people in the Julia world who are very interested in it, but we have all sorts of the typical string functions. Let me copy this thing up here and then we can continue. So we can take the length of a string, we can do lowercase string, we can strip it of its white space. And all sorts of other functions. If you're interested in any of these, you can go to the website and just copy them into the help prompt, or you can look at the manual. I don't think I've talked about the manual so far, but at docs.julialang.org is probably your best resource for learning Julia, even from other people. There's an extensive manual about how to use Julia, the ins and outs. So if there's a question that you have that isn't answered here and you don't feel comfortable asking about it, the manual is quite long. You will find your answer in there almost certainly. All right, we've seen printing already, so I won't go over that again, but I will go over our first macro of the day, and that is the show function. So if I have 2 variables x and y, and I show their addition, you get sort of the expression that generated the value, and those are tied together. You'll also notice that we returned the value afterwards. So if I wanted to do sort of 3 plus at show x plus y, that works as well. So the value passes through the macro, but it will print things out. This is very valuable for debugging. If you don't want to go through the debugging loop in VS Code, if you don't want to install GDB, print debugging is perfectly fine. I highly recommend it. And show is typically your best friend there. There are some really complicated ways of using strings in Julia called styled strings. If you want to make sort of really artsy things in the terminal, you can create some crazy, I haven't actually tested this one, but you can, sorry, you can't see that, can you? You can create a lot of crazy things. This is obviously not crazy, but there are a lot of packages that will help you sort of build up some pretty interesting stuff. Let's see.
I have a quick question.
Hmm?
In the examples, you use a semicolon after show. With this, does that just suppress? And can you use that for?
It suppresses printing the output. So if I do @show x plus y again, and I do that, it will print the thing that it intended to print, but it won't sort of show the return value, right? Julia is mostly an expression-oriented language, so most things return a value. And Julia's REPL will by default print that thing so that you can see it. The way to suppress that is the semicolon. The semicolon can also be used to sort of create a new line. That's its other sort of use. If you have a single long line that you want to stay one line for whatever reason, but it's technically two expressions, you can use it for that. But yeah, so this, because @show returns the value, it prints it. This doesn't happen in Julia if you're sort of running a function or, you know, you're not in the REPL, right? If you're in a file, right, it's not printing things every time that you return something. It's just for ease of use that anything that's returned to the REPL is printed. All right. I might stop here for a brief moment to see if I can try a little bit of an experiment. So bear with me. I am going to have you all clone a repository. Does everybody know how to git clone? I'm going to assume that's a yes. So if you would please clone this, let's see. I don't know how to make this any bigger. This repository, it's very small. It's just a project file. Jesus. So just clone that into a folder of your choosing. It's, like I said, just a folder and a project file. Once everybody has had a chance to do that, I will actually go ahead and do that too, so I don't do something strange.
I have no idea how to get one.
Yeah. You don't know how to get clone?
Nope.
Can you type the word git in your sort of terminal?
Yeah.
And do -- version to see if it exists and press enter? Did something pop up?
No, desktop.
Does not? Let's see. What I'm going to have you do is, unless they figure out how to. Got it? Okay. So I am in this folder here, same as you. Oh my goodness. Keeping this at the top is very difficult. Okay. So the first thing is, how do we start Julia in a project? The first thing you can do is you can just start Julia like normal. I don't know why it's doing this. The first thing you can do is just start it in a project like normal, and you'll notice that you are in just the global environment at v1.12. If you want to then activate the folder that you're in, you can do activate period, right? If you want to activate something else, you can type in something else instead of the period, right? A different folder. But I'm going to go ahead and do that. And you'll see I've activated the project at temp teaching QNumerics. This should be the thing that you get cloned. And the first thing I'm going to type is instantiate. Instantiate is that sort of resolution process I mentioned to you, where it tries to figure out the maximum versions across all the packages that it can install without violating any of the dependencies. So I do not know how long this will take you on each of your computers. I believe it will be faster for me because I already have all of these packages installed. But this could take a while for each of you. That's the repo we cloned, and then I went into the directory and launched Julia from there. The other way that you can do this is project, just like that. And you'll notice that we are in the QNumerics folder. So there are two options. The first is that you just launch Julia with no arguments, and then you have to do the activate from within Julia. If you launch Julia with the project argument here, sorry, I apologize for sort of the change in size constantly happening here. If I do this, this will automatically sort of do the activation for me. I've got some questions in the back. Yep.
Is this any different from going to shell in Julia and then cloning, going into the directory and then?
Yep. There was a hand up and then I'll grab you. Yeah.
The text is very hard to read.
I don't think I can make it any.
Yeah, the brightness, I think, is part of the issue. Is there any way?
I can't turn up the brightness any further. I can try to find a font which is would it help to do light mode?
Yeah, that's.
Is that better?
That's it. Sure.
Like higher contrast?
Yeah, it's a bit better.
Okay. The alternative is I can try light mode, I guess. I don't know if that actually works. I guess not. I don't see any difference. Okay. Yep.
Exit out of that.
Yeah. Yeah. So yeah, sorry, I'm jumping around a little bit. I'll try to stop doing that. Yep.
Take it from the beginning. I cloned the repo and also cd to the GitHub repo folder, and then what?
And then you have two options. The first one is to launch Julia with this -- project that activates the folder that you launched Julia in.
Instantiate to download the thing. After you activate things,
You instantiate, yeah, and then we are going to the next thing. So then you should see this in your package REPL. Does everybody see this? QNumerics? All right. The next thing.
Installing.
Still
installing.
Okay. Yep. Activate just puts you in the namespace, essentially. It just puts you in the right place. It doesn't do anything else. It sort of doesn't do anything to your state. It doesn't change anything intentionally. And that's the whole goal. Yeah. After precompile. Yeah. Yeah.
That's good.
Yeah.
Okay.
Yeah.
I was gonna say.
Yeah.
In the project right now?
It should be.
So this is the sort of waste. So you just don't. So you just can't use it. You can still.
I guess so. So yeah, like if you don't instantiate. Yeah, so like the first time you run it, but then it will remember. So that like,
So if you do LS.
I mean, it will remember. So like if you have to like do all this stuff, but then when for the first time, then you get all this. Like, as needed. Right.
Julia
Okay.
We did this so that we don't have to do this.
I don't know.
But we could have just been coding and stuff, and then once we get one.
Yeah, but
Oh.
okay, but you went into this other.
so that's why we did.
Yeah, you gotta go into REPL mode to do it, I think.
The activate is. Right, what's the activate?
Yeah, I'm a little.
Everything you install is in this folder. Otherwise, Julia starts.
Okay, but
Are you familiar with Conda environment?
did the activate thing
So
ever?
basically, in Julia, every package can activate the Conda environment for itself. Like there's no, yeah, it's every time you create a project, you also create an environment. So basically, activate tells you, okay, let's activate this the virtual environment.
And then this is just now precompile all those.
What's up?
I think you have to activate it in.
So is this the virtual environment for Julia, or is there a virtual?
I can walk through it one more time. Would that help anybody?
Yes.
Okay.
Whenever you create a project in Julia package, it's both a package and it's also a virtual.
Give me one sec. I think I can turn off this like weird changing of profiles thing here.
Run down.
So you don't need to open it up.
Goodbye, sweet.
Everyone will know.
Okay.
Now the whole.
All right. So I'm back in an empty directory. There's nothing here. I'm going to do git clone of this string. This is the GitHub repo. It just has a project file in it. Has everybody gotten past this part? No? You still aren't able to clone?
I'm actually, it's taking a little bit of time to make a GitHub account. Yeah.
You shouldn't need a GitHub account to clone.
It's requiring like a username.
So in the meantime, something that might be faster than that, if you go to this website, github.com/raygun/QNumerics, there is the project.toml there. Just download that file and put it in a folder. That'll probably be faster.
A path of where it gets called. How do you get where it gets called?
I can show you.
There is an extra J.
Now you have this. Can you just type in that?
Yes, you type in Julia. Space. Or yeah, you just wanted Julia. I watched it in the way that
Oh, yeah, so you could, next week, like, I could go into your.
Shows.
yeah, and then try QNumerics stuff.
All right.
And the right bracket. And then file.
Yeah, you already have.
Do again. It's also like yeah. See if that.
I just did that if you're comfortable.
So there are two opticals. Yeah, it's doing
You right away changed it to.
If you see the other
They gave us some instructions on them. I don't know if it matters.
Yeah.
here is like.
Not that I know what you do.
And then you just did the pre-compile.
You already know. Then just do recompile or instantiate on those two in the package.
Yeah. Okay, so yeah, even though we're.
All right. I'm going to move along from the clone. I'm going to start Julia in this project folder. So I'm going to CD into QNumerics. So I am inside the folder and I'm going to launch Julia. When I use that -- project with no extra arguments, that means use the project folder where I am. If that didn't work, if you didn't end up with the QNumerics project right here in the package REPL, you can also do activate and then type in the path or use a period if you know you're already there. So you should be here, at least you should see QNumerics next to the package REPL prompt, which again, you get to with the right square bracket. The next thing you can do is one of precompile. I would just type precompile. That's probably easiest. So precompile will take care of every step that we need to get through to move along for the rest of the things here. And so you can see the first thing it will do, it will update the registries, it will download things, and then it may take some more time for you if you don't already have those packages installed elsewhere on your machine. I do, but it might take a while. You might see some spinning for quite a while. If you see only green, you're good. It's still working. If you see some red, let me know, but you probably shouldn't. So let's see.
I have a quick question. What's the difference between like precompile and instantiate? Like what's?
So I told people to do precompile because precompile will call instantiate for you. But instantiate is that thing we talked about earlier where it tries to figure out what versions are available of each package and how it can sort of stitch them together, right? Because there may be some packages that rely on a certain version of another package and another package relies on a different version of that same package, right? And so they have to find sort of the lowest common denominator in order to download the packages. And that's what the instantiate step is. If you just type precompile, it should take care of all of that for you. But if you are, for instance, developing a package and you don't want to do the precompilation step, you can type instantiate and it will just sort of resolve the dependencies, but it won't do anything else. But because we're using things, we'll do the precompilation.
Gotcha.
Yep.
Are there any like errors, like bad image errors? Would recommend that you use
You get bad what errors?
bad image.
Bad image.
Not downloading certain.
And if it doesn't work. Well, I guess because we already did so.
Yeah.
I've never heard that one before.
Right? Compiling packages. But I did. Your downloads just red.
Stefan will grab you. Yeah. I can't hear you, sorry.
I got an error. You can check.
You're right.
Okay, it says I do it in that, so. Package mode.
But you could probably replace it.
Because you can yeah, you just
I guess I'll just.
Oh, actually, it might be. It's probably because you passed through.
Like if I-
It's already super easy on WSL. So
Because it was already started.
I think if you're using package, it's like saying import.
Yeah, I think so. And then it does the recompile.
No, I think it's just, I think it's like, if it exists, it just takes it, if not, it imports.
I was just saying that.
Yeah, let's go. Yeah, let's go. That's not the same. Yeah, a lot of experiments.
Yes, I think if it doesn't exist, it's just they're highly related.
Yeah, I bet that's like one thing.
Like that's my.
It's like when I tried to speak Italian. But I didn't catch it. It's like, oh, no.
I was working on like the gravity.
So it's more
generous.
Oh, import. Oh, from math, import.
Okay. How about you?
Yeah, I was buying it on. Repeated.
It's like putting it on like standby and just calling. Yeah, so then it's like you call everything.
I feel like I never saw this version from this, that.
So from math import so it's just import math. And from math import what you want. Then it's much faster.
Right. But so I've seen people do this.
Yeah, but that's equivalent to saying import.
So it is just preference.
So like 12:30 and up.
Yeah.
That's going a little. Sounds a little 55 continuing.
So you won't be able to use this discourse.
Yes, I guess you guys.
But it's sort of show how this stuff works.
No, Sunday morning, yeah, I checked out 11.
I didn't
Then when
I didn't like something. Did they say congratulations?
Yeah, he actually got 3 extra.
He got a premiere. Oh, yes.
Oh, yeah, for dinner. The lady letting us in. But then
Then what is it for lunch?
go from here.
Oh, yeah, yeah.
I had a good time.
For
It's pretty nice, right? It's like, I mean, I don't know if it's different.
If you have that, are you?
There's another one, there's the other one has like
Oh, I was just trying that. This type of error, you probably will guess. This type of error is like that.
That's really fun.
Share bunch of binary contains instructions that you're not supposed to run either on this version of tuples or on this processor. It's a pretty modern normal processor, so one thing you can try is to go to the compile, to start from scratch. This error is not supposed to happen, so this is just kind of a thing to try. Maybe there's some bug in the initial setup and you just happen to stumble upon
I think it's like if you know someone else is gonna look at it, then it's because some people like they know someone's gonna look at it. You're like, I
if that one still works though, just sticking to that might be the simplest.
They can still be nice. They can still be nice.
Unless you do like very grounded. Like. Like just, yeah. It's like, I mean, I've seen anything.
Yeah, that's
yeah, maybe I don't think. I want to try it.
That is so crazy. It's also
Does he look on the correction? That's a good yeah, because it's higher. Yeah, exactly. Yeah. I don't know how to not read. I sent a text to say another matter. You can find out about it. Say that this beautiful thing is mine is already I don't know. I just pretending I was asleep. I just pretended I was asleep. So everything is like put in a part. I said something or I get to put it up. She said something. There's free time.
Yeah, I say like.
I'm going straight to my wedding.
It was already
Where's which guy?
Not this. Right now, maybe says expired, but I'm going to go and try to come back.
Get a new one? Like
I just don't think it's
No.
up to Karamaki.
F1, because I'm on OPT.
That's fine. If we use Karamaki.
You were given some notation that
I'm just joking.
just potentially within the folder that
Yes.
We should all
So everyone is expecting to track. Yeah, but for some reason it might just be like 1 bit different. When it shows up, then it's like that's. I'm going to invite everyone. Is there a conference?
So you can.
We can organize one.
If you organize a conference, then I can use the funds.
In the hall.
And the Slack.
Coincidentally, in the same hall, the previous year there's a conference.
Yeah, yeah. No, I'm the only one who posted exactly.
Possible.
I don't know if you thought I was
I wonder who is gonna read the entirety of my.
That might be now
You did all this in a single week.
There's no like.
The second one just like I'm complaining about. Yeah, I think I have some of
And then in like it's already
no, not fair. 3-4 days, it's like non-stop. Yeah, it's not looking forward to it. There's something for everyone, but I guess it depends how much exactly.
His friends came in the night and like one of zero.
Like that? Like that?
Oh, I see. His friends came like excited, so he stays up. So he's energetic.
It's not fun, it's like continuous something or other.
Every Indian let's just talk about this one because it's also used for some fun.
I think like maybe the theory is nice, like something like that. I mean, it's hard, but like
Oh, yeah, good to go now.
Not, this is not medical advice. I'm just from experience.
Don't ask any other.
Yeah, I mean, comes from Afghanistan. No,
Yeah, it's not in India, but it's not that common.
Punjab is anyways famous. Notorious.
I'm thinking like,
But they don't have it like even illegal. They just don't grow it. Like there's a mountains right closer to Afghanistan.
maybe doing like natural
But in India, it's like I think there's a board that actually grows percent controls. So technically, there's some part of
It's a
it is legal.
controlled, so there's like farms will grow.
So it's like licensed farming.
Probably we should have. I found this also in Instagram.
We have something like
It's just, it knows everything.
All right, is everybody mostly to the point where, just look at my, just look at the right-hand side here, where they have sort of QNumerics, they have their packages, things seem okay, no big red errors. All right, we're gonna try something. I don't know if it will work, but it might be a little bit fun if it does. So it was Katie, what was the name of that? Oh, it's right here, actually, never mind. So if you guys would do this command here up in the top left, if you can see that I just highlighted. So I will try to zoom in here. It will mess it up, but let's see. So in that REPL, you're going to do using quiz student. You're not being graded, by the way. The quiz is a misnomer here. And then you're going to type that in. The room key is correct, but obviously your name is probably not your name, right? in all caps. So name yourself something relatively reasonable, please. So I don't have to kick people. But oh, sorry, I'll bring it back. My bad. I didn't know that would disappear. You got one person? Oh, I'm gonna join too, actually.
So it's a S calculation. I mean, everything is responsible, and then you want to do all this. I can send it to you. Yeah.
All right.
I mean, change your name.
I was about to do
it.
Hey folks, a lot of these commands will also be dropped in the Juliaup channel, just so you can copy paste if necessary.
Yeah, that's it. You just can do it. I mean, that should be like 6.5.
I'm gonna really quick make an adjustment. I won't make it disappear.
Join room.
Is this still at the top?
Oh, this is why I made a typo. Oh no, right. So inside of this waiting. Where is it? SS. Are you up there? Six. So room key. Yeah, right over mine. It was like
You don't like yeah, but that's
doing your PhD information. That's the hope. I would be. Oh, it's just the dark. I thought it was that one to get a job. Yeah. But we'll see how it goes. I'm really interested in
I believe you should carry your book.
I'm not sure why there's like 200 people. And because there were only like 90 on the email.
Suppose reveal your dashboard for dashboarding.
So
Can you come out? I will not be able to respond for like quite some time.
Like the QuantumSavory students.
Or maybe
Really? No, I think now try dashboard. Dashboard is the
no, I'm still learning to be it.
I think dashboard is a command in that package. But dashboard is
It says that is to the
I think that makes sense. But then this is it's like
when it's like you don't know what it is, but
Same as a question. Yeah.
All right. There are only about 48 of you connected, but I'm going to move along. If you need help connecting, please look for somebody next to you because a little more than half of you have connected. So, like I said, not graded, just for fun. Ooh, one guy. So you will notice that you got this little quiz student thing here. Oh, you guys probably can't see that, can you? I'm going to move this one to the top. It should say something like quiz student, Raye is in the room. It's my GitHub handle. It should be your name or something similar to it. So what this package does is it adds a new REPL mode, right? We talked about the original 4. There's the normal REPL, there's the package REPL, there's the help REPL. REPL stands for read, eval, print, loop, in case you want to know, but it doesn't really matter what it stands for. So if I press right parentheses, it will bring me into the quiz REPL. You don't actually have to do this because I can force you into it at any time. Not really forced, but like it'll just jump you into it for a second to answer the question. And you can always press backspace. I'm not like actually controlling your computer. I believe it is next Q. Can't actually see anything because Zoom is always in the way. It's just ask. All right. So you should have, yeah.
Did you say that this was the 4th mode, or did you say that this is like to add a mode?
This adds another mode. So it's just the adds one that's accessed by the parentheses. It's just a fun little package. And it's for asking questions of the audience, essentially. So the 4 are the help REPL, the normal mode, like where you type things normally, the package mode, and the shell mode. Right?
Okay.
I guess the timer went out. It looks like I don't even know what the question was, to be honest. And thank you. So it looks like I should really have changed how this displays, but it looks like some of us have been programming for 7 to 15 years, but quite a few 3 to 7, very few less than 1. But that could be because it's the 32 that didn't make it into the quiz. That would have answered 1 there. Like I said, if you need help getting in, please ask your neighbors. How many participants we have now? 50. It's going up slowly. All right. This is just to get an idea for how the rest of the day is spent mostly. Okay, not many.
In the class.
Once this one ends, I will ask the next one.
We just opened it.
I wrote this, right? Like they were like, oh, open parallel, close parallel, voltage. Have you written meaningful code? Well, define meaningful, but yeah.
There's like more than print line, you know, there's more than opening it and exiting it. Yeah.
Meaningful for others or could be meaningful for yourself?
Only ever meaningful for yourself. I've never written anything meaningful for others. In fact, I try not to. All right. I don't know what I'm doing. Wrong.
Okay, so
some company.
Huh?
When you pass, also meaningful to the yeah, I get
Boo. Mathematica, that's not so bad, you know. I can forgive you for that. There's nothing else quite like Mathematica.
Then you get out and you're like,
Wow, nobody loves R anymore. R used to be really popular. I'm going to move them along a little bit quicker than 30 seconds. Otherwise, we'll be here all day. No rustations. Or gophers, I guess.
So much code, I don't even know the company runs it.
How vibe coded? Very.
How do we use the resume token if the connection's closed?
How do you use the token?
Yeah.
It should, just don't type in the token again, and it should work. If not, just change the name and it should let you back in with a different name. It's all in Tachikoma, Stefan, which was itself vibe coded, so you know. Yeah.
Does that count?
I mean, it works, you know.
Oh, yes. So good. It was so good. They were like,
Functional.
All no functional programmers in the house. Very sad.
non-trivial code written back. Non-trivial
I think there's some people overestimating how much bash they've written here.
like it ran somewhere, did something.
Okay, we're just gonna get through the last few, I think.
Amazing.
Can you put more?
If it's useful to be plywood, but I would have to read through every line. I'm not gonna publish something that I didn't read. Right?
Yeah, I think I'm fine too.
I will use it in a class in a classroom setting, but like I don't. I think in particular because there's security implications. Like there's a VPS running a bounce server that like, and I don't want to.
Yeah, but they said
Have somebody doing something that is probably executable, right? Okay, yeah. I'm hoping it works well for the teaching part here in a second. I have some more. All right. Wow, not a single sparse person? That's so sad. That's all I do. And not a single autodiff person. That's very different from last year, actually. All right.
what's the primary setting?
A temper.
I don't know. Yeah, yeah, of course. Yeah, I need to over the lunch break. I'll change all this looks. Wow, lots of academics. Are there any more questions? Answer these ones fast. I'm going to run through to the very end so we can get back to learning. I can see why nobody likes the bare REPL. Yikes. Oh. Afternoon, we'll get to it, I promise. VS Code. All right. This should have been the first question. Wow, interesting. Yeah. Have you ever opened a pull request to an open source project? That's pretty good. Hmm?
I haven't contributed.
Oh, okay. It's fine. I'm the lazy committer, you know. I won't judge. Have you ever published a package or registered a package? It's a big first step for a lot of people. All right. I don't even know how you answer this. Oh, it just lets you type. Well, it's not going to tell me anything right now, so I'll give you 1 minute. Either one. I don't know.
I didn't take it. I don't know what it is. I think you have to put
Respond
response.
and then parentheses and then.
You have to write respond. And then
Probably wasn't quite so useful to have everybody's name just in the middle of the screen.
Open double quotes. And you took it? Oh, you have to put.
Oh, there's a cheeky your name in there. I see you. Oh, I do get to see it actually. Practice GPU allocation. Interesting.
Maybe.
Like Slurm?
Maybe
We can do Slurm. Guess.
I think maybe because you put.
No. Right. How you go to the quiz
Okay.
plugins?
We are done. All right. So my plan is to teach the rest of the sort of syntax and basic parts of Julia using this quiz system. So the idea is I'll teach a little bit and I'll ask you a question. I don't have the questions in front of me because I just have the one screen. So they're just going to come out at random because I don't know what they say because I can't read them. So, all right, let's move along here. I'm going to exit this REPL since I don't need to be there anymore. All right. The question is, vibe coded application, can I change the bank without restarting the room?
So she's gonna ask a question and then you're going to. So it just pops up.
Does anybody see the word bank? Oh, load bank. Oh, method matching. Strange. Anyone want to see what the inside of this looks like? That probably works. Okay. Quizzes. Starting. Ooh. I'm going to assume that worked. Clear. Ask. Nope, it didn't work. Let's see here. Fortunately, I might have to make you type in a new token. I will fix this after the lunch or before lunch ends, but that's going to be all right. Oh, don't look at that. You're not allowed to see that. Host quiz. All right. New little token here. You obviously don't have to do using quiz student again, hopefully, unless you've exited your Julia entirely. Everything is the same except for the room key. I'll leave this up for a little bit, and then we will move along.
We need to back out the quiz before we enter the quiz.
Can you just do join quiz? What happens if you do that?
I could try.
I can just send you one.
Just use the command over.
Yeah, I did close the other one. There should be heartbeats. Sorry. Okay. We're getting some participants. All right. So the last thing we did in terms of content before we took a little segue to see if things worked. Basic arithmetic and comparison operators look as they do in most languages. Plus, minus, times, division. Division always returns a float. Yep.
It says the quiz is closed. It's too late.
The AMK one?
AMK9.
Is anybody else still joining? There's still people connecting.
Also gives me the same.
Maybe I should back out.
I probably spelled it wrong.
You can always just exit the Julia session and then rejoin with the using quiz student. We haven't used any other packages, so. Oh yeah, if you're in the quiz REPL, I don't know what happens then. So the backslash division always returns a floating point number, float 32 or float 64, depending on what it is. If you want integer division, truncating division, so 5 divided by 2 is, I don't remember, 2 or 3, one of them, 2. Then you have to use the slash div sign. So it makes an actual division symbol. That's how you get access to integer division. There's no sort of silent conversion there. Remainder, the percent sign, very normal. Unlike, I think Python, exponentiation is just sort of the caret. It's not, times. Inequality, inequality, equals equals is equality. Not equals, sort of exclamation point equals. You can also type the LaTeX not EQ if you really want the fancy sort of slash over your equal sign. The next ones are pretty simple too. Greater than, less than, greater than or equal to. You can get the nice greater than or equal to things with LaTeX just the same if you want things to be concise. The last thing is a little bit special. It is equality by identity. I won't talk too much about this because it doesn't typically come up too much, but there's a lot of ideas of identity or equality in the world, right? There is sort of numeric equality. If 1 is equal to 2, the integers. There is approximate equality. Floating point numbers, you can't often do exact equality. So that's a different form of equality, which you can type as, hopefully everybody's in, but you can type as approx, just approx, I guess, actually, if you're looking for approximately equal. And that will compare sort of with some tolerance between the two numbers. If you're still looking to join, I'll put this back up here. Yep.
How would you set that tolerance, or what's the default tolerance?
there are other functions. That's for the operator, which I think is like, I don't remember off the top of my head. It's in the docs. But if you want to set the tolerance, I think it's is-prox is the function. And there's, I think, a few other ones. I wish I could just write AM9KK and K9KK. Anyway. The next operations are the updating operators. So some languages have these updating operators that are their own atomic operation, right? In C++, I believe you can overload the updating operator for a specific type. In Julia, they just desugar to, in this case, x equals x plus pi, for instance, for the x plus equals pi. There's no sort of overloadable operator here. It's just syntactic sugar. So I can copy all of these. And then I'll copy this one. I don't know why, but yeah. That can sometimes cause a problem if you're trying to write code that's very, very similar to C++ code. Let's see. I don't know if there's a question. Let's see. Does everybody have a question? I can't even tell what it is. Oh, wait. I have this thing. So remember how to type the LaTeX symbols. You do backslash. I think that's the backslash. I hope so. And then you can tab complete, and everybody should hopefully see that that's a pi symbol. So if I go along, I'm going to do pi. Like that.
Oh, so you start with the backslash and then type like this into your
all right. The next nice bit of syntax, hopefully. Oh, actually, a lot of people haven't answered yet.
Yeah, it's kind of like.
Yeah.
All right. The next nice thing is what we call juxtaposition syntax. So if you ever had to write an equation that's like 3 times, and it ends up looking really long and kind of cruddy. In Julia, juxtaposition of sort of a numeric literal, like 3 or like, I'll bring out the imaginary numbers here. That's complex. Juxtaposition of those literals against a variable implies multiplication. So if I set x equal to 10, then just copy this. Then I can write my equation a lot shorter like that. This is true also for other things. So for instance, if you want to multiply an array by a constant or a matrix by a constant, you can just put the constant in the front and it will do the multiplication. So that's a nice little bit of syntax if you're writing a lot of equations. Like I mentioned before, you cannot use integers in if statements. So for instance, if 0, we will get a type error. Like I mentioned before, that is a non-Boolean, it's an int64. And so if I wanted to do this, I would have to do something like, I don't actually know what the goal is here, but it seems like it was false. So something like that. I have to do a comparison in order to get a Boolean out that I can use in my if and else expressions. That's not even, I seem to have lost a bunch of my code in formatting issues. So, like I said before, Julia is mostly an expression-oriented language. So this if statement, it does something, right? Inside there's a branch and I can print, I can return, for instance. But if I don't return out of the function, I the if statement itself will return the last value that it encountered, in this case 10. It could be something completely different, but that's important to keep in mind if you accidentally do an assignment or something like that. But this is also pretty useful. I'll do another little question here. I think that's about juxtaposition. You can only do it if it's not a complete statement, I think. Like y equals if x is greater than 0, it knows that that is not done.
Semicolon?
Oh, I think I should have taught something else here first. All right, so what this wanted you to do was to first assign x equals to 2 outside of the quiz REPL. I should have been more clear about that. The alternative here is our first new bit of syntax is the begin block. So if you want to cordon code off from each other, you can type begin and end. Most of our blocks in Julia use end as their end. So if I wanted to here, for instance, I wanted to do our shenanigans. There, I get that right. Yep.
Show. Once you hit enter and begin, click submitted.
Oh, it got rid of, this is not REPL output. Yes, I appreciate it. I had it hidden because I wanted to sort of go through it, but yeah, good point. I'll keep it up. All right, so the begin block is one example of a way to split up your code. There's not a ton of reasons to use it. The big one is something called sort of do blocks, very similar to begin blocks. And then the next block is let blocks. So if I wanted to sort of have some scope here, let's say I had this x equals to 10 here, and I wanted in this scope x equal to be 2, without getting rid of that 10. I get 25 and my x is still 10. So let allows you to sort of introduce a new block of scope without erasing everything you've done previously. If you want to shadow variables is what we call that. That's something pretty common. But yeah, if you need to answer something in the quiz, you can press backspace to do other things and then write your answer in the quiz and it will use those variables, or you can type it as a block. Those are sort of the two options that you have. Yeah.
If you have, say, more variables than just one that you want to fix for a certain session, say X and Y, how would you do that?
I think it's a comma. I don't do this very often, honestly, because I don't, shadowing is kind of weird, but go away. Whatever. Yep, it's a comma. Yeah.
After you create your begin and end, how are you adding new lines in between?
So you should in the REPL, you should type the begin, type your lines, then type the end.
Oh, okay. So there's no way to
there are, but I just don't know them off the top of my head. But yeah, typically you should write things in the REPL sort of linearly, right? It's just easier to do it that way. It also prevents you from accidentally flubbing the enter key and having to start over. Ternary looks like in most languages, question mark, semicolon. It returns the value of the expression. Short circuiting. This might look a little bit strange. Most languages have short circuiting conditionals. So if you have an if statement and 2 branches, a short circuiting conditional will not evaluate both branches. It will just, sorry, I'm not being very precise with that. If you have a double ampersand for and, right? A short circuiting conditional will look at the first result, right? If it should be a Boolean, And if it's false, it knows it doesn't have to look at the second one, right? Because it's an and, the and function. That's what we call short circuiting. It won't evaluate the second function or the second argument if it doesn't need to. The opposite is sort of true with or. If the first argument is true, you don't care, right? You can continue along. Most languages want you to use these things in if statements, but you can also, in Julia, you can use them kind of anywhere. And so a lot of people use these to write sort of short conditionals. So if I type, this first one here, x is greater than 0. We know from earlier somewhere x is 10. We don't know yet what the result of this function will be. And so we still have to evaluate the print line yes. And so we will print that line. The same is true here, right? We get a false, but we don't know what the answer to the or function, the or short circuiting conditional is here. So we have to evaluate the second one. You will see this a lot. It's very terse. A lot of people like it. If it's unclear to you when you're writing code, you don't like this format, just use if statements and else statements, right? There's no reason to torture yourself to sort of try and figure out, especially if you start to chain these things together. A lot of people will make some very obtuse code this way. Relatedly, I don't think I did a full sort of else if x is greater than this else if is how you do sort of a next conditional branch, but not the final one. It's one word, not two. And then else is the final one. And I should probably indent these. Indentation in Julia doesn't really matter, largely speaking. White space, unlike Python, Julia is not a super white space sensitive language. That show X. And we got the last one because both of those conditionals were false. I don't know what the next little question is here. Remember, you probably need a little bit of LaTeX here. Not to type, I guess, just to.
Yeah, the sentence there. Yeah, I use the same.
Looks like most people got the right answer, that the division symbol is the truncating division for integers. Now, finally, we get to functional abstraction. We can make some functions here. So functions in Julia are spelled out fully. It's not func, it's not f, it's not def, it's function. You can typically autocomplete that and potentially everything else in your environment. That is an expression, so I've returned the add function, right? I can assign f to it. A and s is the last thing that happened in the REPL. So f equals a and s. These are the same things. That was the triple equals right there for identity. And you apply functions with parentheses, like pretty much every other language, except functional ones, I guess. The return statement there was optional. If it's pretty obvious what the return statement is to you, the programmer, you can leave it off and it will just return the last thing that it encounters. So if it was just x plus y, it would return x plus y without the keyword. I and many others don't really like that. It should typically be pretty explicit when you return something. It can be hard to read control flow otherwise, but just so when you're reading other people's code, you may not always see the return function. So just the last thing that is written is the last thing returned. So this clamp positive right here may return, right, in this conditional branch here with this short circuiting conditional, but it may just return the X if not. You can also write functions in short form. So I can write mul xy equals x times y. That's a function as well. If you have a long, this only works on a single line, right? So you have the equal sign and it's for simple mathematical forms. Otherwise, if you have things that span multiple lines, you are strongly recommended to use the full long form syntax. And of course, in this case, the return is pretty much always implicit. The final way that you can write functions is anonymous form. So both of the previous times we have named this function, mul for one of them, add for the other one. But we don't have to. This next format is anonymous. So you'll notice that I get the return value of executing it. But here, if I just don't execute that function, I get this generic function with no name. It's the 6th generic function that I've created or something. This is useful when you do something like the map function, right? You can pass in an anonymous function. You don't actually care what the name of the function is. You only use it once. If you reuse this function more than 1 or 2 times, I recommend naming it, right? Because you will trigger recompilation every time this function is encountered again, if it's anonymous. I can name the result of this, right? But that's not the same as the name of a function, right? This f can be redefined, whereas I can't redefine mul quite as easily. If you try really hard, you can figure it out, but you shouldn't. All right. You may have seen a few times already types somewhere around the bool, int64. Every value in Julia, except for whatever that last thing is, has a type. I don't know why that's formatted like that. What I was trying to do is what I was trying to say is even functions have types. The type of a function is the type of the function. It doesn't really have another name than that. Yeah.
How do you erase like a stored function?
You can't really erase functions in Julia. This is actually kind of a little bit of a problem right now in the sense that if you have a long-running Julia session that does a lot of compilation, and there's some tools that cause extra compilation that we'll look at later, essentially compiling it in a different way to, for instance, give you type checking or new errors or something like that. You can eventually sort of overflow your memory, right? If you keep defining functions. You almost never do, right? You have to be a compiler engineer pretty much to be regularly overflowing from generating functions. They're very small, but Julia doesn't garbage collect functions. They're assumed to sort of always be there until you exit the session, in which case they disappear forever, unless you save them in a file, right? This is something they're probably going to change soon, where functions may be garbage collected, specifically because the next gen version of the Julia VS Code extension pretty much requires that you be able to throw away compilation because it does this analysis essentially, where it uses the Julia compiler to tell you certain things. We call it abstract interpretation, where it might tell you, oh, this branch is never taken, or oh, this type is incorrect, right? And it uses the Julia compiler to do that. And right now that compilation never goes away, which is a problem. So yeah, right now you cannot reassign functions to make them disappear. I can do that with like X, for instance, right? I can set X equal to the special value nothing. And nothing is nothing. And now X is equal to nothing. It's not gone, right? It is equal to a value. But if you want it to sort of be useless, you can set it equal to nothing so you don't get confused. The type of nothing is fascinatingly capital nothing.
That's cool.
This is very common. We'll see this in a little bit with when we talk more about types. But typically, if you have what are called singleton types, right? There's only one nothing. You'll have the type nothing, and then just its only member, right? The lowercase constant nothing. Yeah, so like I said, everything has a type. In C++, you might be familiar with this idea that if you pass, for instance, for C++ developers, if you pass a dog, like the struct dog, into a function that takes only types of animal, right? You can typically only access the methods of the sort of the class animal, right? You can't treat it as a dog because the function has essentially erased that information. In Julia, it's the opposite. Julia values always keep their type, and sometimes the compiler can't quite figure out what that type is, and so it becomes a runtime thing. And this is sort of the big performance thing that we'll be trying to deal with in the second session later. But yeah, that's a big thing to keep in mind. Julia values always know their type, no matter what. They never forget. They never think, oh, I might be, just a real number instead of a flip 64. They always know their type. All right, talk about the beginnings of some composite types here. The first thing is tuples. Or E in my tuple. All right. Tuples are kind of like static collections of arbitrary data. So this first tuple, my tuple, contains a string and then a float 64, another string, contains the type of function, and then it contains another string. If I look at the type of my tuple, you will see that it looks exactly like that. It is the tuple type parameterized by these types here. This is a little bit strange and a little bit problematic sometimes. So tuple types sort of always are pretty much, most of the time, are exact. So you can imagine if I have a lot of tuples of all sorts of different types running around my program, then I might sort of explode the number of things I have to compile. The other thing is that they are immutable. So I can't do my tuple of 1. I can do my tuple of 1, but I can't do brown. I don't know. That's a method error. We're going to encounter a lot of those, but that essentially means there's no method, there's no function for now defined on this type for get index or set index, sorry. You can do some fancy things with tuples, like, for instance, you can unpack them. ABC equals my tuple. That means A is purple, B is pie, and C is people. If you want to collect the rest of the tuple, you can do this nice little collect syntax, so ellipsis here. This will come back again and again. It essentially means take all these things and cram them together, typically in a tuple. And so A is still purple, but B is the rest of the tuple. And I can iterate over the tuple and all that sort of stuff. Yeah, so this next thing is, we're going to ignore this next line until the next session because it's more about the type system. But for now, I want you to sort of begin to think about tuples as a representation of the signature of a function. So if I have a function f that takes ABC, right? It takes 3 values. You can represent that as a tuple, right? 3 values, and that tuple has the exact type, of each of those 3 values. This will come in handy later, a fair amount. But yeah, that's an easy way to think of tuples. Is it's like the arguments to a function, yeah, it's used quite a lot in that regard. Named tuples are pretty similar, except instead of numbers, each field has a name, right? My name is purple, my value is pi, and my function is type of. It's not all that different. The types look a little bit different, but otherwise they're the exact same as tuples. They just have names instead of indices. You might think of them for the future as keyword arguments, right? If you have keywords to a function, which you can do. Sorry, I didn't mention this earlier, but right, I can have A, B, C, and then typically after a semicolon to separate them. It's nice. I don't think you always have to do this, but can't name it foo now. Z equals 10. That shows Z. All right. I didn't rename that function there, but I added a method, which we'll talk about a lot. That's sort of the core idea of Julia. And if I just put garbage into this, it's keyword argument, but also it has a default value, and that default value is 10. So keywords come after the semicolon. What are they called? I don't remember. Positional arguments come before the semicolon. The next bit of syntax we'll start to encounter a lot are vectors. Vectors are very different than tuples. Vectors are mutable, first of all. Most vectors are mutable. So v1 equals 10. And then if I look at v again, it's been changed. This is your basic sort of array in Julia is the vector. You have some nice syntax for the beginning of an array, and you have some nice syntax for the end. Like I said, you can change the value. You can push to them, so they are not statically sized, much to many people's chagrin. So you can see that I have made this vector a little bit bigger. And if we look at the type of, just as a preview, you can see that unlike well, I guess they're all integers here, but if I had a tuple of integers, I wouldn't have just like tuple integer. It would be, if I had 4 integers, it would be tuple integer, 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 right? There is a slot for each value. That is not true of vectors, right? The type of the vector, the element type of the vector is for every value in the vector. I can make vectors of non-homogeneous types. So I can do a string and a float, and I get a vector of any. Any is most of the time a pretty scary thing to encounter in Julia, because this means that the compiler can't do much at all, right? If Julia can't tell what the types of something are, it can't optimize about the size. It has to pass them in a special box that carries the type around. It can't compile the rest of the functions that you call on it, already knowing the type. So when you see the any type, sometimes it's okay, right? Sometimes it doesn't matter if you're dealing with things that aren't computationally intensive. Who cares? But if you're dealing with sort of a hot loop in a Fourier transform or a tensor network computation, an eigenvalue solver, and you see an any, sometimes it will be in red for some of our tools because it is quite bad. Julia can't really do what it does best, and that is compile with any. Ranges are like lazy vectors. Yes.
I have a question real fast on the any thing. So in those 2 examples where you have a vector of n64 and then you have a vector of any, do you know off the top of your head how the computer is storing those in memory?
Yep.
Like what the, I guess, fundamental difference there is?
So you should have in your project the about package, capital about, and you can do using about. And it nicely tells you quite a few things. I'm not sure that it's actually going to tell you explicitly what you wanted, but I will tell you separately. So if I want to know more about a value, specifically about how it's stored or how it is represented, especially if it's sort of deeply nested, then I can use the about package made by a very nice member of our community. And you can actually customize what the about function shows for, your own types. In this case, the representation of the V vector, which is homogeneous, right? It's just in64. It's a memory ref of type in64 inside, which doesn't really tell you much, right? It's just passing the buck to the next guy. But it also stores a size, which is 8 bytes for the size. The memory ref, you can see, is constant, also has the in64. And then inside it's a pointer, right, to a single buffer, which you can see here, right?
So it's a contiguous block.
It's a contiguous block of memory, yeah. That is not the case with this guy, although it might not quite show it in the way that I want to. Oh, it kind of does. You can see how like this is a continuous block of memory here, right? Whereas here we have this pointer, this void pointer to another pointer. And so what happens is these values are boxed, which means that they carry a type tag with them, because Julia can't tell a priori what they are. And then it's pointers all the way down, essentially.
So we could go back and forth to the key.
Sure. There is, in certain cases, there are small union optimizations and like type tag optimizations. So for instance, if we're able to store the tag in the pointer itself, because if you're not aware, we have 64-bit machines, but we actually only use 48 bits of that pointer because none of us have enough memory, even if we could afford it. Yeah, so you can do some tagging, you can do some optimizations, and Julia has some very clever optimizations. But in general, when you have an any, it's a pointer to something that has been boxed. I think it's actually core.box. Yeah, it's not documented because they don't want you to touch it, but it is core.box is the sort of representation of something that Julia doesn't understand. Or sorry, can't tell what it is based on context. I feel like it's time for a question, so I can drink some water for a second, which I don't have any of.
Another question.
Yeah.
What's the syntax for push? Why does it have an exclamation mark when looking at it?
So the Julia community, and certainly Julia base itself, has a sort of my brain is completely fried. It's a stylistic decision that most of the community has made. Whenever something mutates a value or mutates something that is mutable, we add an exclamation point at the end of the function. It's not required by the language. Like I could write push without it, and nobody would complain except for other people who would be sort of like a little bit upset about it. But if you write a function that mutates something, then you should probably add an exclamation point at the end of your function.
It's the grammar of the push exclamation mark is the function.
Yeah. Yeah. It's not, there's no like the exclamation point isn't something separate. You can put exclamation point anywhere in a function, I think, except for first, maybe, because I think that means not, but like, yeah. It's just sort of something that we do stylistically. It's not. Same with how we capitalize types and lowercase functions. I believe it's possible people had disconnected. No? If you're able to type it in your, all right, we're not grading it. If you're able to type it in your REPL and see that it looks right, then I will try to fix any little disconnection bugs over the break. So we were talking about ranges. So ranges are lazy vectors essentially, or you can maybe also think of them as lazy tuples, but vast majority of the time we would think of them as lazy vectors. So 1 through 5 represents 1 through 5. But if we look at R here, we will see that it is just two 8-byte values and not, the actual values 1 through 5 stored. So this is an abstract range, which is subtyped by ordinal range, unit range, and we get all the way down to the concrete type unit range here. We can also do this guy here, 0, and then we take 0.25 steps, and then we get to 1. This is a step range. You can use step ranges also with integers, if you want to count it by 5 every time. Unlike Python, I think Python sort of takes the step and puts it at the end. Is that correct? Does anybody know? Yeah. Julia, the step is in the middle where it belongs. Because I'm flabbergasted by that. Dictionaries, the dict is a built-in type. This copy function does not work very well, it seems. Dictionaries are the same in pretty much every language, right? It's an associative array. Instead of being indexed by the numbers 0 or 1 through m, it's indexed by arbitrary things. I also said 0 just there by accident. Julia is 1 based, if you haven't noticed already. So start counting your indices at 1. I'm very sorry if that is frustrating. It's very nice for certain areas of math, is largely why it was chosen. Julia shares a lot of DNA with MATLAB in that regard. You can see the type of this dictionary. It's a dictionary where the key is a string and the value is an integer. So every key will be a string, every value will be an integer. Yeah, pretty straightforward. Mixed keys, mixed values will collapse that type to any, right? And you'll notice here a new type. Real is an abstract type. It's up in the type hierarchy, above integer, above float 64, above most of the numbers except for complex. So Julia doesn't necessarily immediately give up completely, right? It can try and track up the tree, but if it hits any, you're stuck. And sometimes it will give up before, going all the way up the tree. Real, though, isn't all that much better than any. It might help you be able to tell, the next function takes a real, so I can compile it for reals. But it's still a pointer to something, right? Because it has to track that it, is the specific type that it is. If Julia is able to tell, oh, real only actually has 2 subtypes, it might do that optimization that I was just talking about, where it can tag in the pointers because it knows statically that there's only, I don't know, int 32 and int 64. Loops look like loops, and you type in for loops. Be very careful when you type these things that you don't type that. For various reasons, most of which were probably silly in retrospect, scalars, numbers, are iterable. So, for I in 3, doesn't really make much sense. Most of the time you meant 1 to 3, right? But unfortunately, we're stuck with this. It's kind of how a lot of the rest of the syntax works, is by having numbers be iterable. You can also use the symbol in from LaTeX, which I like to do, but a lot of other people really hate. While loops look like this. Apparently they don't. Oh, because n doesn't exist. My bad. There is no do while loop. So if you want to sort of have a while loop that always runs once, you have to sort of make your condition amenable to that. Do while loops in some languages, right? They check the condition at the end of the loop. In Julia, you have to sort of figure that out yourself. It's typically not too hard, but we don't have that naturally. If you'd like, you can always write a macro for it, but as I mentioned, don't write macros unless you can avoid it. All right, I'm gonna ask a question so I don't get too far ahead of myself. Oh yeah, this is pretty far ahead actually, or far back rather. Sorry, when I say bind, that means assigned to a variable, right? So greeting equals. And you can always check this in your REPL before submitting it. Just click the backspace to get out of the quiz, and then you can go back in with the parentheses.
What's the dollar sign?
Worded a little weirdly, but this is essentially asking you to compute the 4 within the string using string interpolation. We did very early, so it might have gone by some people. String interpolation looks like this. 2 plus 2 equals, we use the $sign for string interpolation. And then I can write anything in here, right? I can write print line for God knows why, or like, 10 plus 10. If I'm just doing a variable, I don't need the parentheses. I can just do like x. X is nothing if you remember from way back when.
Oh, this is what is. It's was forward, but you don't like.
People still answering or?
It timed out.
It timed out, okay.
Quickly.
I don't know why it doesn't tell me that. I wish it did. Anyway, I'll ask another one here in a second, but most of the interface for vector, yep.
Could you show it the answer?
I can write it out. It is greeting equals 2 plus 2 equals, and then this would be 4 or, square root of 16 or whatever. It doesn't actually matter what it is, but it's just that you need to interpolate the 4 in there. It's just a way, just teaching string interpolation, how much you can do inside of it. You can put anything in there. There is no difference in this case, right? It's just for teaching purposes. But for instance, if you had a big long string where it's like, a greeting card that you need to send to a million people, right? You might interpolate, people's names from a database, right? And then you need string interpolation. You maybe do computation in there. So these exclamation point functions are basically the sort of mutable vector interface for pushing and popping. You can push values, that puts them at the end. Popping returns the value at the end. You can push first and you can pop first in the same way. I strongly recommend you don't do this very much. Most programming languages work best when things stay about the same size. If you're constantly changing the size of things, that means something has to move or get copied or reallocated. So most of the time, since you're all here for science largely speaking, you will just sort of allocate your vectors and they will stay that size their entire lifetime. There are basic aggregate functions. So you can take the length of a vector, you can take the sum of a vector, the product of a vector. Pretty straightforward. You can reduce with the plus, right, to get the same as the sum approximately. It's a little bit different when you're using floating point numbers. They do different algorithms. I think one does Kahan summation and the other just does straightforward, just adding them up. So if you care a lot about numerical stability, then you might choose to use sum instead of reduce plus. And notice here, this might be the first time we've passed a function as data. So functions are values just like anything else, except you can't rename them, right? You can take the maximum, but you can't take the max. Max is only for 2 values, same with min. I don't know why, but yeah, you can get the extrema, and you can take the sum of a range, for instance, and this nicely never allocates the full vector for you, right? You don't have to create every value in between and then sum them up. Yeah.
Sorry, what is the reduce?
Reduce function will take sort of any iterable list of values and reduce over them, essentially put them all together using whatever function is the first argument. So if you put plus, it will add them all up. If you put maximum, it will take the maximum. Well, sorry, if you put max, which is the two element sort of max function, it will take the pairwise max and find the max value in the entire array. You can put any function in here, right? That sort of takes 2 values and produces one.
So for plus, sorry, what is the second value?
The second value is the thing that you are summing over. So V here is a vector.
Oh, okay.
Yeah. Sorry, V is this vector. Just like I think Python and many other languages, we have these nice little generators too. You can do this both within certain functions and within sort of generator like array generators. So if I wanted to generate an array that was x squared for x in 1 to 10, this takes the sum of it, and this just gives me that array, right? It can be a little bit finicky how these work, like when you can do what, but for simple things that take vectors, this almost always works. We can slice arrays, so 2 to 4, you know, be 2 to the end. You can do end minus 2 to the end. You can do arithmetic with these begin and end symbols, and that works just fine. And maybe we'll see, so I don't get too far ahead of me. I'm going to ask the next one because we've moved way past the ternary. So define an anonymous function. Remember, a function that has no name, and then give it a name, unfortunately, or a binding rather, for the cube function, essentially.
That's true.
You need the function itself, not the result of applying it. And remember, you can check in the REPL before you submit it. Yeah, it's only 60 seconds, I think. I will make the next ones longer. Well, we can keep going to the very end if you want some real questions, but
Assign this old expression, which is the anonymous function, to
let me skip through for a few here.
for this, that's equal to
This actually might have skipped ahead a little bit.
What is it mutating call?
yeah.
Map. Yeah, I didn't get this. I skipped one too far ahead in search of where we were. You can do map. You can do, let's show these. Yeah, that one's going to be hard to do in 60 seconds. All right, let's just move on. I'll try to fix the timings for the next one. You can search. I'll move pretty quick actually, so we can get to lunch. You can search, and we see a little bit of new syntax for the first time in a while. If we set v equal to this thing here, find first equals 5 of v. Can anybody guess how this works? We just do equals 5, produces this interesting little type called fix2. Essentially, it fixes this value, the 5, and it produces another function that is the equals function with 5 as a constant on the one side. So you can search for things that are equal to 5. You can search for, find all that are greater than 3 using this. And that produces the same thing, fix2. This fixes the second argument. Any is another searching function. So I have the function isEven, which is one of Julia's base functions, and I apply any to the vector with isEven, and I get true because there are values in V that are even. If I look for all isEven, that's false, right? Because we have over here, we have 9 and 5 and 1. But all is probably greater than 0, and that is true. And we can do other things, like we can count all of the isEvens. Let me see here. You'll notice that this next set of functions here on the left, these transformations, map is the first one. So map and reduce are pretty classic functions, right? Reduce takes a collection and produces a single value at the end most of the time. Map takes a collection and just sort of applies the function elementwise. So we create this anonymous function x squared, and we apply it to V, and we've squared every element. We can then do other sort of transforms here. We can filter for isEven. And notice that we still have V here because we haven't mutated V. But I believe there is like a filter bang, and that would change V, right? We filter out the values and we keep the ones that are even. And then we can sort them. And I believe there's also a sort. Yeah, there's also a mutating sort. So most of these transforms that we've looked at have a mutating version. It's up to you whether you think it's important to sort of reduce the amount of allocations that you have, right? Reduce the amount of extra memory you use, or whether it's important to sort of keep or keep things sort of like pure, I guess is the right word. So you're not modifying existing variables. Something that's purity is something very common in like functional programming, for instance. We already looked at some of the comprehensions, but here's some more. If I wanted to generate the x squareds for 1 through 5, I can even filter, right? If I put in for x in 1 to 10, if isEven x, it'll filter out the values in 1 to 10 that are not even. And you can do further things like, more complicated comprehensions to generate other kinds of data. This generates, right, the matrix that is its coordinates. And that brings us to matrices, pretty much Julia's original purpose in being. The first matrix I'll make is just a random 5 by 5. And you can see it's of type matrix. We have vector matrix, and then the next type up, if you have a 3-dimensional matrix, or a 3-dimensional array, is just array, and everything after that is just array. But we have special names for vector and matrix. And there's lots of different ways to write matrices. I won't get into all of these because some of them are a little weird and navel-gazy. But I can do things like take the size, and I get a tuple of 3 by 3. By default, yeah. You can pass in your range. So if I want to do rand of float 64, Oh, that one just defaults to 0 through 1, I think. But I can pass in my range. So if I wanted, I guess I could do rand, is it negative inf to inf? This might give me something better. Nope, that's not going to work. Well, I'll try to figure out how to do that. Is it rand term? Rand n? Wait. I don't remember. But we can look it up together. So the first thing that you can pass is the RNG. If you have, you need a static RNG, you won't typically do that very much. The next thing you can do is pass a set. So it could be an indexable collection, could be an object, could be a string, right? Randomize the string. It can be one of these types. I actually think rand of float by default, it's just we happen to get between 0 and 1. Rand n, I think, is between 0 and 1. We can also ask for the number of dimensions of A. So we get 2. We can ask for the element type of A. Well, A looks to be a string there, but for capital A, we get N64. And we can do slicing too. So A with the colon, we get a slice, a vector specifically of A. We can slice in the other direction. And there's plenty of other array functions. They're all on the website. You can check them out and look at the help. They're mostly pretty straightforward. Oh, there's your answer. Uniform on 0, 1, and then standard normal for this one. You can do the ones. I think the only one missing from MATLAB is like magic, I think. You could generate a magic matrix. I don't actually remember what that does. And then we get to multiplication, linear algebra. A is 3 by 3. We set v to 1, 2, 3. This is integers. We can do a times v. We don't need to use the at like Python. We can do a times a or a squared, which is the same thing. We can take the adjoint, the transpose for integers. In complex numbers it matters, but for reals and integers it's the same as transpose. And you'll notice that this doesn't say 3 by 3 matrix. It says 3 by 3 adjoint matrix, and that's because the type of that thing is this adjoint. It's a lazy adjoint. So it doesn't actually transpose the matrix. It wraps it and says if somebody wants to use the fact that it's transposed later, they can. Otherwise, they can copy it and make a normal matrix again. And that's the transposed matrix that we've just sort of materialized. In addition, we can do the opposite of multiplication. We can do a solve. Of course, it has to convert to floats. The default Julia installation does not have exact solves in it. But backslash, just like MATLAB, if you're familiar with that, works for most matrix types. Sum on a matrix by default will reduce the entire thing, but you can say you want to reduce on the first dimension. You do dimensions equals 1, sum on the second dimension, dimensions equals 2. So the first one takes the column sums, the second one takes the row sums. And we can make some of these things that we've been doing a little bit easier. So if I wanted to add 10 to a matrix, I could map, right? I could do the map between plus and the vector and 10. Or I can just do this nice simple broadcasting syntax. So if I try to do v plus 10, what is v? Yeah, it does not work. If I try to do v dot plus 10, it does work. So broadcasting, if you're familiar with Python, it's not super surprising. Some of the shapes might be a little bit different. Just watch out for that. But essentially, the dot will apply things element-wise. So if I have foo from somewhere, I assume I have foo of AB, so I can do 1, 2, 3, 4, 5, 6. Don't worry about that methods thing. We'll talk about that in the second session. But I can apply foo element-wise to 1, 2, 3, and 4, 5, 6. And if I recall correctly, foo was the sum function or the addition function. I can apply sine element-wise to v, and you'll note that it promotes to float because it has to. I can take the square root, etc. I can also apply this to our ranges. So if I, not v, sine. If I want to do the sine function across a range without allocating the range, this allocates no data in doing so. It just, it allocates the output here as a vector, but as it's calculating things, it doesn't do that. Yeah.
So, sorry, what happens if you do sine without the dot on a vector?
You get no method matching the unit range, right? There's no hard and fast rule that you can't write a function that takes a vector, right? Like it's perfectly possible for me to write sine and that takes a vector and returns, the element-wise sign. But in general, at least Juliaup base and most of us, if there's an element-wise function, you shouldn't just take it and apply it element-wise, or sorry, if there's like a scalar valued function, you shouldn't take it and apply it to the whole array. You should try to be clear that, you have to broadcast over it or write a for loop because they're equivalent, right? Another nice thing about this is I might take the sine of v dot plus the cosine of v. The cool part about this is that I didn't allocate intermediates. So if I did cosine of v, then sine of v, then added them together, I'd have 3 allocations, right? I would have created 3 new vectors. The broadcasting saves all of that, and we just get the 1 allocation on the output. And I can even v dot equals, I can't, because I'm trying to store floats into an integer, but if we did v equals float 64 dot v, and then did this, we can save all allocations completely. This just does pure computation. There's no memory, doesn't create any new vectors. And you can do this with things that aren't numbers, right? This guy here uses our string interpolation. It says, hi, Alice, hi, Bob, hi, Carol, right? So anything that is iterable can essentially be broadcasted over. If you don't want to write all those dots from what I did earlier here, you can take them away. And you can use our, I think maybe second cool little macro of the day, at dot. This just says everywhere that I have a function, I put a dot, or an operator, sorry. So I don't have to, if I have like a 20 function, 20 operator long string, then I can avoid all that typing, which, isn't that much, but you can. Broadcasting, I think, just like Python, also works with dimensions that do not match, right? So if I have a row matrix and a column vector, vectors are always column vectors in Julia, right? If I have column here and I take the transpose and copy it, wait, what? Copy. Select. There we go. That seems unlikely to me. 80?
So
What? Copy of an adjoint isn't always semantically a copy? Isn't it? I thought you always copied out the wrapper. Anyway, but you extrude over dimensions if the dimensions don't match. So, right, I have a row vector, I have a column vector. In order to make them match for broadcasting, I essentially fill in the gaps. I make a matrix. It's the outer sum. You're familiar with that. All right. I think we are actually at lunchtime.
Yes.
Yeah.